All right, we're going to do some examples here for 7.2. Again, these are straight from your book. It's example 1, so just open your book. You can follow right along. Example 1 asks us to find the volume of the solid generated by taking the area under the square root of sine x. That's our function. They restricted the domain for us, so it's just from 0 to pi. And we're rotating this about the x-axis. Okay? So I want you to imagine taking this area, okay? The square root of sine x is just kind of like a little flattened. It looks like a sine function, just a little thicker. Anyway, we want to take this and we want to rotate it down here. So you get this kind of 3D object that's a little bit egg-shaped. So hopefully you can kind of visualize that. But that's our solid of rotation, okay? What we're doing is we're imagining slicing these into discs, okay? Really, really flat pancakes. And we're going to find the area of all those discs and add them together. Now, the way I remember if I'm in dx or dy is I think about dx, remember that's a delta x, that's the change. So I want you to think about the width of your pancake, okay? So the width of your pancake is right here. That is in the x direction, okay? So that means we're going to be dealing with dx. Can't see that at all. Okay, so, and it's a horizontal axis of rotation. That's another way you can remember it. So everything needs to be in terms of x. We're taking the area of all of these circles and adding them together. So remember, the area of a circle is pi r squared. So pi, but we have a whole bunch of radiuses from 0 to pi. And the radius of each of these circles is determined by the function. So here's our radius, and we want to square it. So that's the integral that we need to set up. And now we're going to do this, and this is actually pretty easy. So if we're going from 0 to pi, the square root of sine x squared is just sine x. Then the antiderivative is negative cosine. We need to evaluate from pi to 0. So we have negative cosine of pi minus negative cosine of 0. Let's see, the cosine of pi is negative 1, so negative negative 1 is 1. Minus minus is going to be plus, and the cosine at 0 is 1. So we get 1 plus 1, which is 2, so our final answer is 2 pi for our volume of that little egg thing that we made. All right, let's check out example number 2. Example number 2 is different. Got some different stuff going on here. So we have a region. You can read this in the book. Find the volume of the solid formed by revolving the region bounded by the graph of f of x and g of x about the line y equals x. Okay, this one's different because we're not revolving around the x or the y-axis. We're actually revolving around a separate line. So let's start graphing this, see what's going on. F of x, this is a parabola that's going down, starts at 2. Okay, so looks like this. You see that okay? Yep. All right, and g of x, this is just a line y equals 1. So this is the region that we're revolving. Okay. We're not revolving around the x-axis, we're revolving it right here. Okay, so this thing's going to come down like this, and it's going to give us a little egg-shaped object right here. Okay, that's what we're trying to find the volume of. And then if you want to draw in all of your little pancakes, your little discs, there they are. Okay, I'll make that one darker so you can actually see it. Okay, so we want to find the volume of this. Again, I want you to think about the width of all of your discs. They are in the x direction, so this is going to be dx. We've also got a horizontal axis of rotation, so that's another way to remember this. And we want to do the area of all of those little circles that we're going to create. Area of the circle is pi r squared. So we're going to do pi, and then all of our circles r squared. We just have to figure out what r is. All right. From where to where? Pretty easy to see that this goes from -1 to 1. Yes, I believe I'm looking at the right problem here. Yep, -1 to 1. And I did graph that pretty well. Okay, so the radius. Now we have to talk about the radius. We want the radius of this circle, okay? That radius. Now, before we always used the function, but the function's way up here, okay? If I do the function value, that's this whole thing, and I don't want all of that. I need to stop it at 1, okay? So we are still going to use that function, this 2 minus x squared, but then since we're revolving around the line y equals 1, we need to subtract that 1 out of it. Okay, so we're going to do 2 minus x squared minus 1. And we're going to square that whole thing. Okay? All right, so when we do that, what do we get? Negative x squared plus 1. Okay. Yep, we're looking good so far. We are going to have to take the antiderivative of this. We should probably just FOIL that out. I think that's going to be the best thing for us. So that's going to give us x to the 4th minus 2x squared plus 1. Yep, so far so good. Now we're going to take the antiderivative. So 1/5 x to the 5th minus 2/3 x cubed plus x from 1 to -1. And then we're going to plug in 1 and -1. So we get 1/5 minus 2/3 plus 1 minus -1/5 plus 2/3 minus 1. And then you can use your calculator, you can get common denominators, whatever you need there. Somebody forgot to write the pi. There's still that pi out front. And once we get all the way through this, 16 pi over 15.